For as long as human civilization has existed, the night sky has inspired questions that no generation could fully answer. Long before powerful telescopes or modern science, people stood beneath the stars and wondered what those distant lights truly were. Across every continent, civilizations created their own stories about the heavens. Some believed the stars were the homes of gods, while others saw them as guides for navigation, calendars, and the changing seasons. Although their explanations differed, they all shared one powerful curiosity: what lies beyond the world we can see? As centuries passed, curiosity slowly transformed into science. Careful observations replaced mythology, and mathematics became the language used to describe the universe. Every new invention revealed that the cosmos was far larger than anyone had imagined. What once appeared to be a small dome filled with stars gradually became an endless universe containing billions of galaxies stretching across unimaginable distances. One of the greatest breakthroughs came during the 20th century with the development of the Big Bang theory. Rather than describing an explosion in empty space, the theory explains that space itself began expanding from an extremely hot and incredibly dense state approximately 13.8 billion years ago. As the universe expanded, it cooled. Tiny particles combined to form atoms. Atoms gathered together under gravity, and over billions of years those atoms became stars, galaxies, and eventually the vast cosmic structures we observe today. This remarkable idea is supported by several independent discoveries. Perhaps the strongest evidence is the cosmic microwave background, a faint glow of ancient radiation that fills every direction in space. It is often described as the oldest light in the universe, released when the cosmos was only a few 100,000 years old. Even after billions of years, that ancient signal continues to travel across space, carrying valuable information about the universe's earliest history. Another important clue comes from distant galaxies. As astronomers study their light, they find that nearly all of them are moving away from us. Their light becomes stretched toward longer, redder wavelengths, a phenomenon known as redshift. The farther away a galaxy is, the faster it appears to recede. This relationship shows that the universe itself is expanding, exactly as the Big Bang model predicts. Large galaxy surveys provide even more support. When scientists map millions of galaxies across enormous distances, they find that matter is not scattered randomly. Instead, galaxies form an intricate cosmic web made of enormous filaments, clusters, and vast empty regions called voids. These structures closely resemble patterns predicted by modern cosmological models, giving researchers increasing confidence in their understanding of how the universe evolved. Yet despite these extraordinary successes, the Big Bang theory does not answer every question. It explains how the universe developed after its earliest moments, but it does not fully explain why the universe began in that particular state or whether anything existed before the expansion started. These unanswered questions remain some of the greatest challenges in modern physics. Another mystery has emerged through increasingly precise measurements of the universe's expansion. Different techniques produce slightly different values for how fast space is growing. Although the disagreement is small, it has become one of the most important puzzles in cosmology. If these measurements are correct, they may indicate that scientists are still missing an important piece of the universe's story. Rather than weakening our understanding, mysteries like these drive scientific progress. Every unexpected observation forces researchers to question old assumptions, test new ideas, and build more accurate models of reality. One of astronomy's greatest strengths is that it allows us to look backward through time. Because light travels at a finite speed, every telescope is also a time machine. When we observe the moon, we see it as it was about 1 second ago. The sun appears as it existed 8 minutes in the past. The most distant galaxies reveal light that began its journey billions of years before Earth even formed. In recent years, this ability has led to astonishing discoveries. New generations of space telescopes have found galaxies that already existed surprisingly soon after the beginning of the universe. Some appear larger, brighter, and more developed than scientists expected. Rather than disproving the Big Bang, these observations suggest that the first generations of stars and galaxies may have formed much faster than earlier models predicted. These discoveries remind us that the universe is never as simple as we imagine. Every new observation expands our knowledge while revealing even deeper mysteries waiting to be explored. After thousands of years of studying the sky, humanity has learned an incredible amount about the cosmos. Yet the farther we look into space, the more we realize how much remains unknown. The greatest discoveries may still lie ahead, hidden among the oldest light in the universe, waiting for the next generation of explorers to uncover them. If the early universe has challenged our understanding of cosmic history, the modern universe presents an even greater mystery. The stars, planets, and galaxies we can see are only a small fraction of what actually exists. In fact, everything visible through even the most powerful telescopes appears to make up only a tiny portion of the entire cosmos. The first clue came when astronomers carefully measured how galaxies rotate. According to the laws of gravity, stars near the outer edges of a galaxy should move much more slowly than those closer to the center. But observations revealed something unexpected. The outer stars were traveling far too fast. Based on the visible matter alone, many galaxies should have flown apart billions of years ago. Something unseen was holding them together. To explain this mystery, scientists proposed the existence of dark matter, an invisible form of matter that does not emit, reflect, or absorb light. Although it cannot be seen directly, its gravitational pull appears to shape galaxies, galaxy clusters, and even the large-scale structure of the universe. Today, dark matter is considered one of the most important ingredients in modern cosmology, yet its true nature remains unknown. But an even greater surprise arrived near the end of the 20th century. Astronomers studying distant exploding stars expected the expansion of the universe to be slowing down because of gravity. Instead, they discovered the exact opposite. The expansion of space was accelerating. Something was pushing galaxies apart faster and faster. To explain this astonishing observation, researchers introduced the idea of dark energy, a mysterious phenomenon believed to fill space itself. Unlike gravity, which pulls matter together, dark energy appears to drive the universe apart on the largest scales. Although scientists estimate that it makes up nearly 70% of the cosmos, no one yet knows what dark energy actually is. Together, dark matter and dark energy dominate the universe, while ordinary matter, the atoms that form stars, planets, oceans, mountains, and every living creature, accounts for only a small percentage of everything that exists. This realization completely transformed humanity's view of reality. Instead of living in a universe made mostly of visible objects, we now understand that the overwhelming majority of the cosmos is invisible and still poorly understood. As technology continues to improve, astronomers are creating the most detailed maps of the universe ever produced. These enormous surveys reveal a breathtaking cosmic web stretching across billions of light years. Galaxies gather into massive clusters connected by long filaments, while enormous empty voids separate these structures across unimaginable distances. Although these patterns generally match theoretical predictions, every new survey uncovers subtle details that challenge existing models. Small differences in galaxy distribution, unexpected structures, and increasingly precise measurements continue to raise new questions about how the universe evolved. Scientists are also refining measurements of the universe's age and expansion using ancient light left behind by the Big Bang. Each improvement increases precision, yet tiny disagreements between different methods continue to persist. These differences may seem insignificant, But across billions of years, even the smallest mismatch could point toward entirely new physics waiting to be discovered. Far from being a completed story, modern cosmology remains one of science's fastest evolving fields. Every powerful new telescope, every deep space survey, and every unexpected observation has the potential to reshape our understanding of the universe. Ideas once considered impossible have become accepted science, while today's greatest mysteries may become tomorrow's breakthroughs. This is the true strength of science. It does not cling to old ideas simply because they are familiar. Instead, it follows the evidence wherever it leads, constantly refining our understanding as new discoveries emerge. The universe has never been obligated to match human expectations. Time and again, it has revealed realities far stranger and more magnificent than anyone imagined. From invisible matter to the accelerating expansion of space, every answer has uncovered even deeper mysteries waiting beyond the horizon. Perhaps that is the greatest lesson the cosmos has to offer. The pursuit of knowledge is not a journey toward a final destination, but an endless exploration. Every generation inherits a clearer picture of the universe than the one before it, yet every discovery also reveals new questions that no one has answered. As we continue searching the depths of space, one truth becomes increasingly clear. The universe is not simply growing in size, it is growing in mystery. And somewhere beyond the limits of today's knowledge, the next great discovery is already waiting to change everything we think we know.